Alrighty, my friends, what is going on? It is another exciting episode of the OChem Rockstars, so you can discover what is possible with you. Now, as you know, we're going to be doing another practice problem, and in this one, I want you to identify whether this is acidic or basic before I decide to dive in. All right, so I'm hoping that you did that. So if we go through here, we can notice if we look at our reagent, I do not see an H+, I do not see an H2SO4, I do not see an HCl, I do not see an acid, so I know it's basic. So if I were going to go through here, I would see that, oh, I've got a metal atom. We talked about that magnesium is a 2+, if we look at the periodic table, which means that whatever is attached to it has to be negative. So that means we have to have 2 minus charges in order to balance our 2+. So we know this is basic. We can see that we talked about this fact that how do we know if it's the C- or the Br- that's going to attack? C is the most important letter in organic chemistry, and particularly if it is negatively charged. So we know that the C- is going to be our go-to right there. All right. So now that we've got that under control, we know that negatively charged are basic. Let's go ahead and look at this. So once again, we know magnesium is 2+, Br is minus, C is minus. We know that we don't pay attention to metal atoms. We know that it's not going to be Br- because carbon is the most important, so I'm going to wipe all of this out, and now we want to look at our CH3-. We've already talked about this, the fact that our oxygen is partially negative, which means our carbons are going to be partially positive. We're going to choose the least substituted one because this is based off of sterics when we have a negative charge. So now what we're going to do is we're going to take our negative charge, it's going to come in and attack that carbon, and we're going to form a bond and break a bond, or lone pair to bond, bond to lone pair, nucleophile to electrophile, however you want to see that. And once again, what I'm going to wind up doing is I'm going to get that, I'm going to drop it down here, and I'm going to draw this. But before I draw this, did any of you notice that I added a lot of carbon framework to this structure? Like a lot more than we really need? The reason I did this is because a lot of professors will throw a lot of stuff on there that's not important. This is what you elite students need to pay attention to, and I know you already are. If you're studying alkyl halides, find the alkyl halide, the carbon and the halogen. If you're studying alkenes, find the alkene. If you're studying the alkyne, find the alkyne. If you're studying epoxides, find the epoxide. So we can see that out of this whole crazy molecule, that's the only area that we need to. All of this over here is a distraction. Professors do this to try to distract you, to get you to look over here, over there, like question yourself, do I know what I'm doing? What's going on? That's why they do it, okay? So I want to point that out now so you know the tricks so you don't get tricked on your exam, okay? If you're studying a function group, zone in, find the function group, focus there, and then go right to it. In this case, since it's epoxides, we're looking for acidic versus basic, and so just don't get distracted with all that, okay? So in this one, let's go back to our mechanism. I just want to point that out. So if this comes in, we're going to get an O- down here, and then we're going to have our CH3 up there. Okay, I just want to draw it this way so you can see that if I keep kind of the ring jacked, we're just going to break that one bond, and we're going to wind up getting an O-. What I want you to do is get in the habit of, when you have these epoxides, so once you get in the habit of drawing your group literally like 180 degrees from your oxygen when they're not a ring, meaning like this. If you have an epoxide, and it's not like this part of a ring, but it's part of like an acyclical thing, get in the habit of kind of drawing it like that, okay, just to get comfortable. Now, when we have that right there, okay, now we've got this intermediate. So what we want to find out over here is what is this going to look like? And I'm going to show you here. This is how I want you to practice. Now, how does this translate into that? If we look at this, watch this. So I'm going to number my carbons. 1, 2, okay? Now, if I look at this right here, let's do it this way, actually. Let's do the whole chain. 1, 2, 3, okay? So now I'm going to go over here, and I'm going to say 1, 2, 3. So I want to be able to keep track of where everything is. And I'm going to go ahead and move this out of the way. So I'm going to go 2 and 3 there. So now I can see if I go along here, and I'm going to number these as well. So we're going to go 1, 2, 3. I can see that on carbon 2, my oxygen with the wedge, this is just another way, is still going to be there. I didn't break my carbon 2 oxygen bond. I'm going to keep that there, so that's still a wedge. But I did add the 3. So what I can do here is I'm going to draw my 3 straight up like that. If you wanted to, you could also draw it out to the side like this and put your CH3 if you want to do that up, down, up, down, up, down. But I want you to kind of get really comfortable starting to draw this, and I'll explain about this further, not in this video, but in another one. I want you to do that so we can see that that's going to be our product. Now you can see the cool thing about when you have negatively charged atoms, you do the mechanisms under like what I consider basic conditions, super fast. Like basically you got 2 arrows and that's done. Remember the acid when you got to protonate, you got to attack, you got to take this off. Here we're just going to come in, boom, step 1, and we're done. That's it. So now what we're going to wind up doing is now we're on step 2. And step 2 is just basically take H3O+, so we're going to do our H3O+, and then this minus right here is just going to grab one of these. We've seen these before, so it's either going to grab that one, or that one. It doesn't matter which one, but that's going to come in and grab one of these H's, so lone pair to bond, or nucleophile to electrophile, and then that bond's going to break. And what that's going to wind up giving us here is now this is going to be an O, and then we're going to have an H. Over here, we're going to have our CH3 attached, and then you can imagine that what we're going to have left over, I'm just going to grab this, would be water floating around. Now, you don't have to draw the water, of course. That's not important, but I'm just going to draw it just so you can see. But you can see that's the mechanism. And under basic, it attacks, breaks a bond, we protonate, and then we're done. And that's it, my friends. As always, so fun to come on here with you. And until next time, I hope you have a good one.